So one of the theories of mind that Jerry Fodor talks about in his essay this week is radical behaviorism. And the radical behaviorists thought that they could do away with this non-physical mind that Descartes had hypothesized, because they thought, well, look, this whole idea of something that's non-physical and yet somehow interacts with the body, that is just some sort of spooky thing, and we don't even know how that would work. So they thought they could get rid of having to posit a mind like that by getting rid of minds altogether. So their hypothesis was, look, we can explain how it is that humans and other animals behave without supposing that they have any beliefs or desires or thoughts whatsoever. We can explain everything in terms of just physical stimuli and physical responses. So they thought they could explain behavior in terms of this law of effect, which just said, look, behaviors, physical behaviors of bodies that are followed by rewards will become more likely, and physical behaviors that are followed by punishments will become less likely. You don't have to talk about people behaving a certain way because of what they think or feel or desire or believe. None of that stuff exists. No thoughts, no beliefs, no desires, no mind necessary. And what the behaviorists were really good at doing was actually conducting experiments to test this theory, to see if they could explain behaviors in terms of the law and effect. So here's one experiment we can take a look at. So we've got kind of a maze here that's just in the shape of a cross. And we've got, say, a rat that you always let into the maze from the upper corner where the rat is there. So now what the law of effect would predict is that first off, the rat is just going to start off and just kind of randomly walk around the maze, nowhere in particular. But every once in a while, the behavior that rat will produce will be to walk its cute little rat feet forward and then walk those feet to the right. And there he'll discover in that the arm of the maze to the rat's right some food, and that will reward that behavior. So the behavior of moving the rat's feet forward and then moving those feet to the right, that behavior keeps getting rewarded. So according to the law of effect, it will start becoming more and more likely. And after a few days, you would expect that every time you release the rat at the top of the maze, it will move his little feet forward and then move them to the right. And so therefore you could explain why the rat always goes right to the food without supposing that the rat believes that the food is located in a particular spot, or without presuming that the rat desires food. It doesn't have any thoughts. It's just following the law of effect. The behavior of moving its paws front and to the right is the behavior that's been rewarded in the past, so it will become more and more likely. Now, this theory, this hypothesis of the law of effect, will also make a really interesting prediction. So, suppose that after you let the rat do this for a couple of days, you then switch things up a bit, and instead of releasing the rat from the top of the maze, you release the rat from the bottom of the maze. Now, the law of effect, remember, would say the behavior that has been rewarded in the past has been the rat moving its little paws forward and then to the right. So that is the behavior that should be most likely when you release the rat at the bottom of the cross there. So what the behaviorist would predict is that when you release the rat at the bottom of the maze, what it would do is follow the arrow and go forward and then to the right, which would take it into the end of the maze that doesn't have any food. Whereas an alternative hypothesis might say, well, gosh, you might suppose that the rat actually does have a mind, and the rat has a belief. It has a belief that the food is located at, say, the western side of the maze, and it has a desire to get that food, and so it's going to act on that desire. And so it reasons, okay, well, I believe that the food is in the western end of the maze, so when I'm released from the north side of the maze, I have to turn to the right to get it, but when I'm released from the south side of the maze, I have to turn to the left to get it. So if we posit that the rat has a mind with beliefs and desires, we'd hypothesize that the rat would go, when released from the bottom, go straight up and then to the left to get to the food, whereas the behaviorists predict, no, the rat would go straight up and then to the right, because turning to the right has always been the behavior that's been rewarded the most. Now, fortunately for us, a couple of really cool middle school students decided to actually run this experiment with their pet rats. So let's see what happened. Here's the video they took. So you can see that we've got the maze set up there. They're starting out on the first day here, releasing the rats from the top end of the maze. And you can see, just as we'd expect, the rats are just they're kind of going around at random. Oh, they found the food there, it looks like. So that behavior of moving straight and to the right has been rewarded once, but, it hasn't been rewarded all that much. So they're still just kind of going around randomly. So now let's fast forward a couple days and see what their behavior looks like after having a couple days to get released from the top of the maze there. And get rewarded with behaviors that take them to the right. So I think this should go to, about day 5 or so. Okay, so after 5 days of this, you can see when they're released from that top of the maze, boom, they just go straight to the right where the food is, exactly like the behaviorists would predict. But of course, that's also what somebody who believes in a mind would predict. The person who believes in a mind would say, well, yeah, the rat believes that the food is in the western end of the maze, so that's exactly where it's going to turn, because it wants food. It has this desire and these beliefs. So the real test here is to see what happens when you release the rats from the other side of the maze. So that's what they do on day 6. Now, for some reason that I don't fully understand, they totally changed the orientation of their video. So, they used to be releasing the rats from up here, and we saw there that the rats would go down and then to the right where the food is. So now, of course, what the behaviorists are going to predict is that now that we're releasing the rats from over here, we should expect the rats to go straight and then turn to the right, because going straight and to the right is the behavior that's always been rewarded in the past. So let's see what the rats do. What? Holy shit. They don't actually go to the right the way the behaviorists would predict. They go to the left, which seems to indicate that, maybe the explanation that the rat believes the food is in the western edge of the maze is correct. And so it is able to reason, to get to the western end, I better turn left this time, even though turning right is what has been rewarded in the past. So this is just one example of one of the many ingenious experiments the behaviorists used to think up or to test their idea, but it turns out that, in the end, they ended up proving it as inadequate to explain rat behavior, let alone human behavior. So that's why Fodor says, this behaviorist thing that we just don't have minds, it kind of fell by its own very ingenious ways of testing it. So that's why Fodors and others start championing this idea that, yes, we do have beliefs and desires, but we don't want to think that those beliefs and desires are spooky, non-physical things, the way that Descartes thought. Princess Elizabeth was absolutely right that we need something that can explain how beliefs and desires influence us physically. So they light on this idea that beliefs and desires are states of a computer program, and in the case of human minds, those states of the computer are being run on neural tissue in our brains. And that's the functionalist approach that Fodor articulates.